I'm going to work out a full proof of L'Hopital's rule. And it is going to take me several videos to do this because there are a lot of different cases and I want to be sure to cover all of them. So in this first video, I'm just going to look at this first case here where we have two functions, f and g, and we know that if you evaluate each of these functions at 0, you will get 0. And we know that they are continuous somewhere. B is somewhere around 0, so b is a positive number, but it's like it could be really, really small, really close to 0. And we would like to show that if you have the limit as x goes to 0 of the quotient of these two functions, we would like to show that this equals the limit as x goes to 0 of the quotient of these two functions' derivatives, provided that this limit exists. And to do this, I'm going to first argue the limit as x goes to 0 from the right, and then I will use that to argue x going to 0 from the left, and then I will use both of those to make a conclusion for the two-sided limit. So I'm going to get a new slide and take a look at the limit as x goes to 0 from the right of f of x over g of x. And of course, all of our initial conditions still hold true. We know that f of 0 and g of 0 are 0, and we know that these functions are continuous at a point b. So what I'm going to do is define a new function. I'm going to define h of x to be f of x times g of our point b minus g of x times f of b. Now you might be wondering, well, why on earth would I want to do that? Well, this function has two known zeros. H of x has a 0 at 0 because if I do that, if I plug in 0 for all of the x's here, we know that by one of our initial conditions that f of 0 and g of 0 are both 0. So when you plug in a 0, you're going to get a 0 minus 0, which is 0. And we also know we have a 0 at b, because if you plug in b for these x's, you'll have f of b times g of b minus g of b times f of b. These two are the same. The order of multiplication doesn't matter. So we can conclude that when we subtract them, of course, we will get 0. So we know that h of b is also 0. Now, when we have a function that has two zeros, we can use Rolle's theorem. And I'll remind you of Rolle's theorem. So if we take a look at the graph of any function that has two zeros, so I'll just draw any function right here, and we'll say it has a 0 at 0 and a 0 at b. By Rolle's theorem, we know that there is a point C in between of 0 and b where this function is flat. So right here, we'll say that this is where the function is flat. And if a function is flat, that means that its derivative at that point is 0. So we know that this h prime of c has to equal 0. So let's go ahead and find h prime of x by just taking the derivative on both sides here. So we know that h prime of x equals, well, g of b is a constant, so I will just keep that. That's a constant multiple. And then the derivative of f of x is f prime of x. And then we will minus, again, we have f of b being a constant multiple. And the derivative of g of x is g prime of x. And we know that h prime of c is 0, which means that if I plug in c for all of these x's, I have to get 0. So I'll say that 0 equals g of b times f prime of c minus f of b times g prime of c. And let me erase this part right here, because now I'm just going to manipulate this equation a little bit. I'm going to add this on both sides, so I'll get f of b times g prime of c equals, this is what I have left over on the right side, g of b times f prime of c. And now I'm just going to separate some things, so I'm going to divide both sides by this, g of b, and I'm also going to divide both sides by this, g prime of c. g prime of c. And as you can see, these will cancel, and these will cancel. And we have f of b over g of b equals f prime of c over g prime of c. And now I'm going to take some limits. I'm going to take the limit as b goes to 0 from the right on both sides. I'm going to take the limit as b goes to 0 from the right, and perhaps I should have left more room here, so let me write it again. So I'm going to take the limit as b goes to 0 from the right, and this was our f prime of c over g prime of c. We are going to do a little squeeze theorem here, because let's see what we know about c. If we take a look at a little number line right here, so here's 0, here's b, and we know that c is between 0 and b. Well, as b goes to 0 from the right, so b is positive, so as we go to 0, by the squeeze theorem, we know that because c is between 0 and b, c is also going to be going to 0. So that means I can replace this b right here with a c, because taking the limit as b goes to 0 from the right is the same as taking the limit as c goes to 0 from the right. And now we are pretty much done. We just have to do some relabeling, because when you have a limit, it doesn't matter what variable you use. So I can call this to be b, or c, or f, or delta, or theta, or whatever I want. So I'm just going to call them both to be x. So I can say that this is the limit as x goes to 0 from the right of f of x over g of x, and I know that this equals the limit as x goes to 0 from the right of f prime of x over g prime of x. And this is what we wanted to prove for our first step, because now that we know this, I can use this to make an argument for x going to 0 from the left. So let's take a look at that. I'm going to get a new slide, and we're going to take a look at the limit as x goes to 0 from the right. Well, actually, now I want to do it from the left, of f of x over g of x. And let me write down our initial conditions again. F of 0 and g of 0 are both 0. We don't care about b anymore. Now, I don't know how to handle x going to 0 from the right, but I do know how to, well, I don't know how to handle x going to 0 from the left, but I do know how to handle x going to 0 from the right. So what I'm going to do is make a substitution in this limit. I'm going to pick a new variable, u, and I'm going to assign that to be negative x. Because that way, as x goes to 0 from the right, if u is negative x, u will be going to 0 from the left. So I can write this limit in terms of u. Say this is the limit as u goes to 0 from the right, f of, well, what's x? Just multiply by the negative 1 on both sides. X is negative u, so I have f of negative u over g of negative u. And as u is approaching 0 to the right, notice that negative u is also going to be approaching to 0. And we know that f of 0 equals 0, and we know that g of 0 equals 0. So we can do what we just proved, because we have u going to 0 from the right. We can conclude, by what we just proved in the previous step, that this is going to be equal to the limit, as u goes to 0 from the right, of whatever I get when I differentiate the top and the bottom. So, if I differentiate the top, if I differentiate f of negative u, I'll get f prime of the same input, negative u. But then keep in mind we have to use the chain rule and multiply by the derivative of the inside, which is negative 1. And on the bottom you basically have the same thing, except with g. So we're going to have a negative g prime of a negative u. And the negatives cancel out. So perhaps I will just erase them. And now I can just put u back as x. And keep in mind, since u is negative x, x was going to 0 from the left. So I can say that this equals the limit as x goes to 0 from the left of f prime of, well, negative u is the same as x, so we have f prime of x over g prime of x. So now I've shown that this equals this. So now I have the right-hand limit and the left-hand limit. So now I'm going to go back to our original slide and make a conclusion about the two-sided limit. So we know that the limit as x goes to 0 from the left of f of x over g of x equals the limit as x goes to 0 from the left of f prime of x over g prime of x. And we can say that the limit as x goes to 0 from the right of f of x over g of x equals the limit as x goes to 0 from the right of f prime of x over g prime of x. So what does this tell us about the two-sided limit? So I'm going to say the limit as x goes to 0 of f of x over g of x, and we want to see if this equals the limit as x goes to 0 of f prime of x over g prime of x. Well, one of our initial conditions is that this limit right here exists. So what does it mean for a limit to exist? That means the left-hand limit and the right-hand limit both have to approach the same value. So that means that the left-hand limit and the right-hand limit have to be the same thing. So I can just erase the minus and the plus, because these both have to equal the limit as x goes to 0 from both sides. So now what about this limit? Well, if we're taking the limit as x goes to 0, that means if we have the left-hand limit and the right-hand limit being equal to the same thing, then the two-sided limit will also be equal to that same thing. Well, the left-hand limit and the right-hand limit both equal the same thing, so therefore the two-sided limit must also equal the same thing. And we have made our conclusion right here.